So now let us look at the third problem from the NCERT book. So which is at room temperature 27 degrees Celsius, the resistance of the heating element is 100 ohm. What is the temperature of the element if the resistance is found to be 117 ohm? Given that temperature coefficient of the material of the resistor is 1.7 into 10 raised to minus 4 per degree Celsius. So first let us write this one. Given given T1 is 27 degrees Celsius with the heating element, that means they have given R1 is 100 ohm and they asked T2 value with R2 is 117 ohm, and they have given temperature coefficient of the material of the resistance, which is 1.7 into 10 raised to minus 7 per degree Celsius. So we have the values of T1, R1, T2, R2 and alpha. How you will find this? See, from the temperature dependence of resistivity, we know the formula that rho T is equal to rho naught into 1 plus alpha T minus T naught. Remember this resistivity. RT means final resistivity and R naught means initial. Same way T is final and T naught is initial temperature. This is temperature. T naught is initial temperature. Okay. So here we have initial, final, right? So I will consider this final resistivity as final resistance, that is R2, and initial resistivity as R1. Okay. In the same way, let us consider this one as T2 and this one as T1. So apply this in that format in this equation, that will be R2 equal to R1 into 1 plus alpha T2 minus T1. Okay, I will solve this. R2 minus R1, no, R2 equal to R1 plus, open the bracket here, R1 alpha T2 minus T1. Okay, so if you apply this here, R2 minus R1 equal to R1 alpha T2 minus T1. Okay, or to remember this during the exam, you can simply write this as delta R equal to R1 alpha delta T. Okay, so now we have the value of R2, R1 and T2, T1 and alpha. We have to find out T2 here. Okay, so apply the values here, that is R2 is 117 minus R1 is 100 equal to 100 alpha T2 minus T1 value is 27. So 117 minus 100 is 70, which is equal to 100 alpha T2 minus 27. Okay. So to solve this, I will write this as 17 divided by 100 into 1.7 into 10 raised to minus 4 equal to T2 minus 27. Write further here, 17 divided by 100 into, we can write this 1.7 as 17 by 10 because there is one value after point, so value is 10, into, we can write this 10 raised to minus 4 as 1 by 10 raised to 4 equal to T2 minus 27. So I can easily cancel here 17 and 0, 1 0 here and 1 0 here. So this value will be 10 raised to plus 3. So plus 3 will go here, which is equal to T2 minus 27. 10 raised to plus 3 means 3 0 after 1. Okay. So minus will be plus 27 here. So T2 value will be 1027 degree Celsius. This is the final temperature of the material.